Hello and welcome to Unit 19, Specific Equipment in the Illustrated Guide to the National Electrical Code. We will be looking today specifically only at a few of the sections that are the more popular sections that you would come across as an electrician. You do need to understand that there are specific code requirements that are established in the National Electrical Code for these specific equipments. So for example, we won't be talking about elevators today because elevator work is done by elevator mechanics. The electrician provides power to the elevator room, and from that point on, an elevator technician then takes it and runs to the cars, the control systems, everything that's inclusive there. So if you were to go in that specialty and go along those lines, then that's going to be an area of the code you're going to be an expert at. But today we want to focus more on EV chargers, electric vehicle chargers, the fire pumps, and we'll spend more time talking about pools, fountains, and bodies of water that man-made like that you would find. These are going to be the more common areas in Southern California you're going to make contact with as far as installing. But again, just understand that there are specific sections for equipment. So if it's electrically connected, there likely is something covering it in the National Electrical Code. Let's first take a look at the electric vehicle charging systems. Now, a few of the important components to understand are first, the electric vehicle storage battery. The electric vehicle storage battery is a battery that is not intended to give off a gas when it's pressured, as you would see with lead acid batteries. It is not a battery that you have to make special provisions for ventilation for either, unlike a battery storage or battery backup system that would be installed at a phone center, for communication systems, at an electric substation for battery backup system. The next is that the output cable to the electric vehicle, and this is defined as the assembly consisting of a length of flexible EV cable and the electric vehicle connector. So this will be coming off of the vehicle or connecting to the vehicle from the charger to the vehicle. Then you have the power cord supply, defined as just a flexible cord attachment with a plug on the end. A plug-in hybrid vehicle is a little bit different because a plug-in hybrid utilizes a gasoline engine, and it also has a battery on it. So the typical hybrid systems, as the vehicle's driving, it will charge the battery. With an electric vehicle, pure electric vehicle, no gasoline engine, but with a plug-in hybrid, you get the best of both worlds. You have the electric vehicle, the electric motor, the electric battery, and the gasoline engine. And it allows you to do two things with a plug-in hybrid. One, you can use the car's battery as a backup to your house. So instead of having a generator, you can pull it off of the car's battery. That's one option. So you can discharge the car's battery into the electric grid or your home. The other is you can charge it by your home when the rates are low overnight. And then when you get up in the morning to go to work, your battery is fully charged and you can drive electric in most of those locations that are close by. A friend of mine has a plug-in hybrid, and his wife drives less than 30 miles to work every day, and she can charge it up, and they hardly even use the gasoline engine for local trips. So it gives you good options of flexibility. But because it plugs in, that's why it's in the code. The rechargeable energy storage system is any power source that has the capability of being charged or discharged. This could be batteries, capacitors, electromagnetic flywheels, for example, of rechargeable energy storage systems. And the EV charging comes from the Article 625 in the National Electrical Code. Now, when we look at the some of the specifications, unless specifically listed or marked for the location, the electric vehicle supply equipment coupling means shall be stored or located at a height not less than 18 inches for indoor locations to 24 inches or above 24 inches for outdoor locations. So these cannot be laying on the connections cannot be laying on the ground. There is a few different chargers out there. The type, like in this picture here, that would mount to the wall and it's a charging unit. This is one option. There are different levels of chargers: level 1, level 2, and level 3. Level 1 is just an extension cord plugged into a 120 outlet into the car. Level 2 uses 240 volt and it charges the car faster. And level 3 is a full charger system that rapidly charges the vehicle. So your level 3s are typically not located at a house, but you can have level 2s located at the house. And those most electric cars now have the capability of knowing when 240 volts applied, then this is a level 2 or 3. If it's 120, then it's a level 1, and it changes the rate of the car charging. And not only is the rate changed, but the amperage draw is much lower as well. So you have to understand when you're connecting and setting up a charger for an electric vehicle, what's the charger type, level 1, level 2, level 3, and then from the manufacturer, what's the amperage draw? They're all different. Tesla is different than BMW. BMW is different than Ford or Chevy. So the manufacturer will provide the amp rating of the outlet or receptacle or the connection point to the charger. So those are things you need to consider. There's kind of some average values that can be used, but specifically when connecting an EV charger, you want to make sure that you connect it properly. Now, I wanted to also point out this one right here. So wireless power transfer, WPT. And this is utilizing, if you guys have a phone and you can take the phone and you can lay it onto a charger and it charges wirelessly, that same technology is being introduced and used in mass transit. And so, for example, they would use electric buses, and at each stop, the bus would come in and it would pick up a charge so that it will charge very rapidly for a short period of time, and then it moves on to the next station or next stop, and it can be charged without plugging it in. So there's a lot of advantages of that. It could be used down in the harbors where they use more electric vehicles now than gasoline vehicles or diesel vehicles. So the wireless charger is new, but it is being stated here in the National Electrical Code. So you have the wireless power transfer using magnetic fields or electric fields, and then you have the transfer equipment that's dealt with in 625.2. So the utilities need to be engaged in this, just as an FYI, because this draws a lot of current for a short period of time, and that has to be accounted for in the electric grid. Fire pumps are the next topic I wanted to cover, because you will run across fire pumps, and being able to understand why they're used and how we need to make sure they're connected. So fire pumps are used to boost the water pressure for fire suppression systems that are installed in buildings. And they may be required because of the large area that needs to be extinguished. In other words, the piping has to be flooded in some cases where it's a dry system. Dry systems are pipes that have no water in them, and then when a fire alarm is set or a flame sensor detects a flame, then it will turn the pump on, and it floods the system and then dumps water in a massive area. The other condition is that the fire pump may not, the water pressure from the city may not be high enough, and the fire pump's required to boost that water pressure for the facility. So there's a couple things that are really important, and they're a little bit contrary. When I was kind of shocked when I first ran across it in the field, but they're contrary to what I had learned in the field before. So when we are connecting a fire pump, and it's going directly to the 480 volt service that is supplied by the utility, we do not install overcurrent protection, a fuse or circuit breaker. And the reason for that is you want the fire to extinguish regardless of an overload. So that motor that's running the fire pump should burn to the ground, figuratively, before you would have a breaker trip. So these will most of the time be line side taps. Line side taps are one of the very few taps that are allowed to be installed ahead of the main breaker for that facility. All right, the next topic is going to be swimming pools, fountains, and similar installations. There's a lot of pools in California. You may be involved with installing electrical for pools, hot tubs, fountains. And what do we remember about the National Electrical Code? Back at the beginning of the class, Article 90.1, what's the purpose of the code? And that's to protect persons and property. There's no better place than around bodies of water that people need to be protected. And the proper installation of the swimming pool, fountains, or hot tubs, whatever other body of water somebody might be in, and electricity is used in that area, it's important that we protect people from electric shock and electrocution. The most important thing to consider when wiring up any electrical device is, can it be reached from the inside of the pool? That means you're in the pool, you've pushed yourself up, you're leaning over your waist onto the side, and you're reaching out and you're trying to plug something in, your radio, whatever it is, into that outlet, and you're doing that while you're in the pool. And if you can do that, then it's installed in the wrong location. So if you think about these requirements from how could somebody die in a pool with electricity, and that consideration to these code sections should help you understand when you're looking at an installation, you think in your mind, could this be reached from the inside of the pool? If so, yes, then you need to go to the code and find out what the specific requirements are. It's interesting that growing up, my parents had an above ground pool set up in the backyard. It was set up right next to the electric panel, and the overhead service drop came over the pole. And my dad says, whatever you do, don't stand up and touch that wire. Okay. Interesting. My brain was thinking electricity at a young age, and I don't know why. Maybe it's just how I was wired, right? Well, I realized that if the birds sat on the wire, they were okay. So if I didn't touch the pool, the water, and the wire at the same time, then I would be okay. So I would jump off of the deck around the above ground pool and slap the overhead wires and jump into the water. Yeah, not a good idea. So when I think of these code sections, I think of the stuff I did when I was a kid. So I want you to just keep that in mind. The second most important thing is grounding and bonding. And so we want to make sure we don't electrocute somebody by having something too close. And we want to make sure that everything is bonded and grounded. And we're going to talk about what those terms are and how that's done generally. Let's look at definitions so we understand what the code means when it uses these terms. When we talk about a self-contained spa or hot tub, we're talking about one that you would buy as a package, and it would be installed, just by setting it on the ground and connecting electrical connection to it with a flexible seal-tight connection and a GFI protected box on the wall somewhere. Something you would buy at a store. It would be delivered all in one piece, and that would be completely self-contained. It has the motors, the heaters, everything's inside. We have the hydro massage bathtub. So these are bathtubs that would be installed inside in a bathroom, and they do have a motor for circulating the water, for pressurizing the water. Typically they don't have a heater, but some of them do have heaters, and you can purchase them to heat the water as you are using it. The next is a wet niche luminary. And if you look into a pool and you see a light in the pool, like this one right here, and the light fixture is flush to the side, then inside of that is a cavity called, right over here, this is called a form shell. And that form shell mounts, is installed before it's gun-sighted, and then when it's all done, that light fits into that form shell. And there is grounding and bonding, I'll show you here in a minute, of that form shell, and the light, the luminary, the wet niche luminary is also grounded. If you see water inside of these, they are bad because they are completely sealed up, and the cord is all sealed by the factory, and you order these for the length that you need, so they have to be custom ordered. I personally prefer not using a 120 volt light anymore, and most of the new pools installed are using LEDs because they can change colors, and they're just more desired by the customer, but they use a low voltage transformer instead of using line voltage of 120 volts. There's storable swimming pools is above grounds, like I mentioned before. There are also packaged hot tub equipment. This can be all together and it can be ready for install. And we also have the non-niche luminary, which would be mounted on the surface. I don't think I've ever run across one of these. So there's not too many of them out there, at least in Southern California. Most are wet niche and most are going to LEDs now. So there's a pool construction called form shells right here, and it's steel walls that get bolted together. And then they could be partially buried or completely buried, and then a vinyl liner can be installed, or it could be reinforced and gun-sighted with steel, with concrete and rebar. So there's a couple different options, but this form shell is conductive. And what you need to keep in mind is when you're talking about these bonding, the conductive pool shell shall be provided as specified in 680, so our pool section is 680.26. And if it's poured concrete, pneumatically applied or sprayed concrete, so that's like the gunite style. And concrete block with painted or plastered coatings shall be considered conductive materials due to the water permeability and porosity. Vinyl liners and fiberglass composite shells shall be considered non-conductive. So your truly non-conductive pool would be a vinyl linered pool with no metal in it, no light, no steps, no ladders, nothing that would have any metal going from the ground or earth around it into the water. And they're non-conductive. Fiberglass is another popular way to go because it's very quick to install it, but it's a completely fiberglass unit that's all set into place. You'll find in the code that a number 8 solid copper wire is what's being used to bond everything together in pool construction. Copper needs to be used so it doesn't corrode, and it stays connected and able to conduct. Now let's talk about the receptacles. So receptacles should not be installed within 6 feet of a pool edge. Here we go again with this idea and understanding that if you're in the pool and you can reach over and plug it in, you're too close. The other thing that's interesting is most extension cords are 6 feet long on appliances. And so if you're within 6 feet, you could get that extension cord, that appliance cord, and it could fall in the water. So just a couple things there to think about. Remember back with dwelling, receptacles need to be within 6 feet. If you're between 6 and 20 feet of a pool edge, it needs to be GFI protected. Now, that would apply inside, because outside it's got to be GFI protected no matter where you put it, but it cannot be within 6 feet. So equipotential bonding is going to be what we'll talk about here for a few minutes, and understanding what does equipotential mean. So this has been introduced previously around cattle, dairies, and where it really was invented for the most part, the equipotential bonding idea, and it was carried over and the idea into pools. Now, I want to caveat that the newer versions of the National Electrical Code, such as 2017 and 2020, specifically 2020, start to remove some of the bonding, the good principles for bonding a pool essentially because of cost. So to install a pool beyond the National Electrical Code, more bonding is going to be a safer installation. I was pleased to hear a friend of mine recently was installing a pool, and they installed it the way that is the best option for the decking, the bonding, and making sure that everything was all tied and connected together. So it made it the safest, not going by the minimum requirements of the National Electrical Code. Equipotential bonding means that we are going to make sure that there's no potential or voltage difference from any points on the pool or around the pool. And the specifics of how we do this are making sure that all metal parts are bonded together. So we're going to look down here at this graphic, and this graphic is showing us that here's our pool, and anything that is around the pool, specifically handrails, ladders, pump, heater, any metal drains, diving board structures, the form shell, all need to be bonded together. And they need to have the same potential. So if you were to contact any of these points, they have the same potential as the water. We need to make sure that the grid is that can be used for part of that equipotential bond is tied together with the copper wiring. So the code is requiring, I believe it's 2020, a minimum of just a number 8 copper wire buried around the pool underneath the slab of concrete. And we see that being used more in the fiber reinforced concrete that's installed. And in parts of California, I have not heard that they're allowing this yet, but I would definitely push back on a pool builder who was just going to bury a copper wire. Testing has been done where fault current has been introduced in the ground around the pool and in the water to see how well that number 8 wire around works in comparison to reinforced concrete with the copper wire attached to the reinforced concrete all the way around. So again, the idea was to use that fiber concrete and not use rebar. But here in California, where we do have earthquakes, it's best to have rebar anyways to avoid the cracking. So all of this being tied together, especially, another thing to consider is an electric cover. But all electric components, all metal components around the pool need to be bonded to create an equipotential bond. Again, the equipotential bond is to have an equal plane, and that would be effectively taking, if you had an equipotential bond between two sides here, that if the voltage potential in the earth rises, everything rises and falls together, and you don't have a voltage difference of potential between these two. But if you didn't bond these, such as the decking around the pool and the pool shell itself, then you could have a potential rise where they're not rising together the same, and you will get a difference of potential between the two, one being higher, one being lower. And if this was a potential of 20 volts and this had a potential of 10, then you'll have a difference of 10 volts of potential difference between the two sources. So we need to have everything bonded together in an equipotential bond. If we're going to install luminaries near a pool, this is a good graphic here to understand how that works. So within 5 feet of the edge of the pool and above 5 feet, there's no luminaries. Up to 5 feet, there are no luminaries permitted in that space. But above 5 feet and within 5 feet of the pool, the GFCI protected existing luminaries. And so we want to make sure that they have to be protected by GFCIs. Above the pool, up to 12 feet, no luminaries are installed. Kind of like slapping that wire I told you about. If you can jump off a diving board or off the side and reach up and slap it, you could potentially be shocked. Now, if you are between 5 and 10 feet from the edge of the pool, and you are above 5 feet, below 5 feet, then you have to GFCI protect that. But if you're above 5 feet and and beyond 5 feet from the pool, so up 5 and beyond 5, then it does not need to be GFCI protected. Underwater luminaries in the pool. So this is the wet niche lighting and the niche here that is put inside of the gunite and the rebar when it's mounted, and then all the concrete is shot in. And the minimum depth needs to be 18 inches. There needs to be a number 8 copper wire bonding the niche to the pool itself, to the rebar. Almost all of them are using a brass conduit, and that brass conduit is going to be filled with water. So you don't want to use rigid conduit because it'll rust. PVC can be installed, but it doesn't provide a good effective ground path. So in this case, brass is used, and brass needs to go up to a junction box. The junction box for the underwater lighting needs to be installed a minimum above the pool decking or maximum water line of 8 inches. So you don't want this to flood, and you're bringing a ground wire and hot neutral up into this box from a panel that's GFCI protected. It makes a splice in here with the wet niche luminary, and that luminary factory cord comes all the way up to here. There's no junctions or splices allowed or made in here. Definitely no, I've heard some kind of horror stories of people taking this light out and then splicing a new light onto it and not changing all of the wire out. Well, now you put the splice in the water. Now you have a good exposure to kill somebody with that installation. So these are all factory installed up to here where you're going to splice them in. Now we'll talk about the spas or hot tubs installed indoors. And here again are our dimensions that we need to make sure that we're aware of. So 12 feet maximum, or up to 12 feet. Anything below that line has got to be GFCI protected. Above it does not require it. And we need to GFCI protect everything 7.5 feet or below for luminaries. And there are no electrical outlets or switches allowed within 6 feet of the edge of the hot tub. Now the hydro massage tubs that are installed in homes, typically this access door, the way it's shown here, is a little different than a typical installation. They're packaged units with everything installed underneath them, and this access door needs to be used typically if it's against an exterior wall. That access door will be outside, and you will be able to reach in there and connect it. It needs to be GFCI protected. And if it is not on an exterior wall, you need to have access to being able to service that without taking the whole tub apart or moving it out. So that's a very quick overview of pools, hot tubs, fire pumps, and EV chargers. Just wanted to give you a quick little lecture here on that, and make sure that you look at the requirements for the homework on this one and follow that. Also, read through the rest of the sections just to be familiar with it so you understand all of the different code sections that are being discussed. And we'll see you in the next one. Take care.